Welcome, students. Today, we're going to do a complete revision of the chapter on gravitation. Our goal is to make sure every single concept is absolutely clear for your exams. Are you ready? Let's begin.
So, here is our roadmap for this revision. We'll start with the biggest idea of all, the universal law of gravitation. Then we'll see how that law applies right here on Earth, and we'll clear up that common confusion between mass and weight. After that, we'll touch upon pressure, and finally, I'll give you some really important tips to help you do well in your exams. We will build each concept step by step.
All right, so let's get started. Have you ever wondered about something really simple? Why is it that when you jump, you always come back down? Or why does the moon circle the Earth so perfectly without just flying off into space? Well, the answer to both of these big questions is actually the same. It's all because of one single, very powerful force.
To understand this, just imagine you're whirling a stone tied to a string. What is stopping that stone from flying away? It's the string, right? The string is constantly pulling the stone towards the center. This pull is a center-seeking force, and it has a special name, centripetal force. Now just think, if the moon is like the stone, what is the invisible string that keeps it going around the Earth?
That is the really big question, isn't it? Obviously, there is no physical string connecting the Earth and the moon. So what is this invisible force that's doing the job? What is this cosmic string that's providing the centripetal force and keeping the moon in its path?
And this is where the great Sir Isaac Newton comes into the picture. He had a moment of genius. He realized that the force that pulls an apple from a tree down to the ground is the very same force that keeps the moon in its orbit around the Earth. He called this universal force the force of gravitation.
Now, this is one of the most important laws in all of physics. It's a fundamental rule of our universe. For your exams, Beta, you must know this definition by heart. It's called a universal law for a reason. It applies to everything, everywhere. So let's look at the formula and break it down.
Okay, let's look closely at this beautiful formula. Here, F is the gravitational force. M and M are the masses of the two objects, and D is the distance between their centers. Now, the most interesting part here is the D squared at the bottom. This is called the inverse square law. It just means that if you double the distance between two objects, the gravitational force between them doesn't become half, it becomes 1/4. Here is a quick summary of all the parts. Now look at G. This is the universal gravitational constant. Its value is the same everywhere in the universe, which is why it's called a constant. A very important tip for your exam. Please pay close attention to the unit for G. It is Newton meters squared per kilogram squared. This is often asked in one-mark questions, so make a note of it.
So, we've talked about this huge universal law, but how does it actually affect us in our day-to-day lives, right here on planet Earth? Let's bring this big idea down to our home.
When an object falls with only the force of gravity acting on it, and nothing else, we say it is in free fall. Now, because of forces acting on it, the object must accelerate. This specific acceleration has a special name. We call it acceleration due to gravity, and we use a small g for it. It is very, very important not to confuse this small g with the capital G we just discussed. They are completely different things. This slide is really quite brilliant. It shows us exactly how we get the formula for G. We just take Newton's second law, F equals mg, and we make it equal to the universal law of gravitation. And when we do that, something amazing happens. Look at step 4. The mass of the falling object, the small m, it just cancels out from both sides. And this tells us something incredible. The acceleration of any falling object does not depend on its own mass. So, if we put the values for the mass of the Earth and the radius of the Earth into that formula, we get the standard value for G, and that value is 9.8 meters per second squared. Please remember this number. You will be using it again and again in your numerical problems.
Now just pause for a moment and try to recall the 3 equations of motion you have already learned. Remember them? Well, the good news is, for any object that is in free fall, you can use the very same equations. All you have to do is replace the acceleration a with our friend g. See? This makes solving gravity problems much, much simpler. Now, this is a very important tip, so listen carefully. One of the most common mistakes students make in exams is with the sign of g. It's actually very simple. If an object is falling downwards, it's moving in the direction of gravity, so we take g as positive.
But if an object is thrown upwards, it is moving against the pull of gravity, so you must use a negative g in your sums. Getting this sign convention right is absolutely key to getting the correct answer.
So, all this talk about gravity leads us to another topic which often confuses students. What is the difference between mass and weight? In everyday language, we use them to mean the same thing, but in physics, they are completely different. Let's clear this up once and for all.
This table really explains it all. Mass is simply the amount of stuff or matter inside an object. It's measured in kilograms. Your mass is the same whether you are on the Earth, on the Moon, or even in deep space. Weight, on the other hand, is a force. It is the force of gravity pulling on that mass. And because g can change from place to place, your weight can also change. Remember, weight is measured in newtons, not kilograms. And here is a perfect example to understand the difference. The Moon's gravity is much weaker than Earth's. In fact, the value of g on the Moon is about 1/6 of what it is here. So what does that mean? It means your mass would be exactly the same on the Moon, but you would weigh only 1/6 of your Earth weight. You would feel so much lighter. Okay, now let's see how forces, like the force of gravity, act on surfaces. I mean, why is it that a sharp knife cuts a vegetable so easily, but a blunt knife struggles? The answer lies in two very important ideas: thrust and pressure.
First, let's talk about thrust. Thrust is just a technical word for any force that is acting perpendicular or at 90 degrees to a surface. But the effect of this thrust really depends on the area over which it is applied. And that's what pressure measures. Pressure is simply the thrust acting on a unit area.
And this simple idea explains so much. A sharp pin has a very, very small area at its tip, right? So even a small force creates a huge amount of pressure, which is why it goes into a board so easily. On the other hand, you can actually lie on a bed of nails because your body's weight is spread out over the large area of all the nail tips. This means the pressure on any single nail is very, very low.
All right, we have covered all the main concepts. Now for the most practical part. How can you use all this knowledge to score full marks in your exam? Let's go through some key strategies that will make you feel confident and prepared.
Please, look at this slide very carefully. These are the most common mistakes that students make year after year. So before your exam, just ask yourself, do I know the difference between g and g? Do I remember that mass is constant but weight can change? And have I double-checked the positive and negative signs for g in my numericals? Avoiding these simple mistakes can save you a lot of marks.
Now, for numericals, if you just follow these steps, you will do very well. It's not just about getting the right number, how you present your answer is also very important. First, always write down all the given data. Second, write the formula you are going to use. Third, and this is very important, check that all your units are in the SI system. And finally, show your calculation clearly and never, ever forget to write the unit with your final answer. This systematic method will help you get full marks.
I'll leave you with one final question to think about. It's a classic physics question. Imagine a place with no air, a vacuum. If you drop an elephant and a feather from the same height, which one will hit the ground first? Just think back to our discussion about free fall and the formula for g. If you know the answer to this, you have truly understood this chapter. All the very best for your exams.